Alright, this is lesson 46, solving rational equations. The goal is you will solve rational equations. That's the objective. And if you remember from before break, rational equations mean just fractions in equations. So this word rational means fractions. And we're dealing with equations finally, which means we're using an equal sign, okay? We're combining what we learned last time with fractions, with polynomials, and solving, okay? Here are the steps. Make each side of the equation over one common denominator. Then we cross multiply, so we're using a little bit of algebra 1 here, pre-algebra stuff here. Right. Combine like terms to one side, factor and solve, and check for excluded solutions. And these excluded solutions, if we have one that is also, that if we solve for an answer and it's also excluded, we call that extraneous. Okay. Meaning it should be an answer, but it's not because it's excluded. So, all right, here we go. Numbers 1 and 2. Watch carefully. So number one, we have k minus 8 over 2k squared minus 1 over k squared, all equal to 1 over 2k squared right here. All right. So the first thing I always want to do is make sure I have a common denominator before I cross multiply and also combine like terms, because I need two fractions equal to each other. Okay, so over here we have 2k squared, over here we have k squared, and over here we have 2k squared. So I know the common denominator is 2k squared. So I know the only thing I have to multiply is this middle term right here, which is by 2. So we're going to multiply that and then combine like terms. So the first numerator and denominator stays the same. We have k minus 8, and then we have negative 1 times 2 is going to be negative 2. And our new common denominator is going to be 2k squared, which is all equal to 1 over 2k squared. Okay, and then I can combine like terms here. Negative 8 and negative 2 is really like saying negative 10, so it's got k minus 10 all over 2k squared is equal to 1 over 2k squared. Alright, so we're going to now have two fractions that are equal to each other. We could use proportions and cross multiply. So we got 2k squared times 1 is going to be 2k squared. And then we got k minus 10 times 2k squared. So this is a binomial, so we're going to multiply it. So k times 2k squared is going to be equal to 2k cubed. Okay? And then negative 10 times 2k squared is negative 20k squared. Okay? Combine like terms now. We could subtract 2k squared on both sides. And we get 0 is equal to 2k cubed minus 22k squared. Alright. At this point, we have everything is equal to 0. When we set things, or solving, you always have to set things equal to 0. When I factor this right hand side, I can factor out 2k squared. So 0 will be equal to 2k squared times the quantity of k minus 11. Okay. Then we want to use the zero product property. We know 2k squared is going to be equal to 0, and we know that k minus 11 is equal to 0. Over here, if I were to solve, we know k would be equal to 0, and we have k is equal to 11 here. Okay. Now at this point, I'm going to go back to my original problem, looking at the very top here. If I'm looking at the very top, I want to make sure none of my denominators are equal to 0. Okay. Because if they're equal to 0, what happens if we have a 0 in our denominator? It's going to be undefined, right? So looking here, 2k squared, what can k not equal to become 0? We don't want it to become 0, so we can't make k equal to 0. That's an excluded value, right? K can't equal to 0 here, and k can't equal to 0 here. But look at my answers. One of my answers is k is equal to 0, right? So is 0? Can we have 0 as a solution? No. So this is called an extraneous solution. So since k is equal to 0, it's one of my answers, but it's an excluded solution. We cross it out down here. If you look down here. And this would be called an extraneous solution. You don't have to write that down every time, extraneous, but you should know what that means. This is an extraneous solution. meaning it should be a solution, but it's not because it is excluded from the beginning. And that's it. That's number 1. Okay, so what did I just do? Again, I needed to combine like terms because I needed a fraction equal to a fraction. So how did I do that? On a common denominator by multiplying this by 2. Multiplied it out and then combined like terms. Now I have 2 fractions equal to each other. Used cross products or cross multiply. And we get 2k squared is equal to 2k cubed minus 20k squared. Combine like terms. Then we factor it out and solve. We know we use the zero product property. K is equal to 0 and k is equal to 11. Thinking back to the beginning, and we got to k, 2k, or k is equal to 11 is your final answer. Okay. Looking at number 2 again. Number 2, we got r minus 7 over 5r plus 1 is equal to r plus 6 over r. So the first thing I want to do is make sure I have a common denominator. This denominator is 1. So the common denominator I need is 5r. So I need to multiply everything so that it's equal to 5r. This one's 5r. This one is not 5r. I'm going to have to multiply this by 5r. And this by 5. Okay, so we got r minus 7 plus 5r all over 5r is equal to, multiply r plus 6 times 5 is going to be 5r plus 30 all over 5r. Okay? That's the first step. Then we're going to combine like terms. I could combine r and 5r to make it 6r minus 7 all over 5r is all equal to 5r plus 30 all over 5r. Okay, now I have 2 fractions equal to each other. Now I can apply cross products or cross multiply. So these 2 numerators are binomials in this example, so we can multiply 6r times 5r is 30r squared. And then we got negative 7 times 5r is negative 35r. Okay, cross multiply again. 5r times 5r is 25r squared. And 5r times 30 is 150r. Okay, combining like terms, now I'm going to subtract 25r on both, or r squared on both sides. When I do that, this first one we get 5r squared here, and these 2 cancel out. And I'm also going to subtract 150r on both sides. So we get, this is going to be negative 185r, all equal to 0. Okay, so now we're going to factor and solve. Okay, so we got 5r, we could factor that out. It's going to be r minus 37, which is all equal to 0. We know 5r is equal to 0, and r minus 37 is equal to 0. It's r. Over here we know r is equal to 0 and r is equal to 37. These are my 2 answers. Now I'm going to go look back to the beginning, and I'm going to ask myself, I'm going to look for any denominators that are going to become 0. So what does r have to be equal to here to become 0? 0, right? Because 5 times 0 is 0, or just 0 here. So we know that r cannot equal to 0. That's an excluded solution. So looking down here, one of my solutions is 0. Is that a solution that we're allowed to have? No, it's an extraneous solution. So we would cross out r is equal to 0, and we would box our answer. So on your answers, you would have to pick the correct answer. You can't put both answers down, right? Even though r is equal to 0 on a test, you can't have it as an answer or a solution. So, okay. Any questions on numbers 1 and 2? Okay. So turn your neighbor. 1 tell the 2's about number 1. 2's tell the 1's about number 2. Ready, set, and go. All right. So continuing on here, number 3. Let's worry about number 3 right now. Okay, so please write this down. Alright, so number 3. First thing we want to do is make sure we have 2 fractions equal to each other. We don't right now because this left side is 2 fractions that are being subtracted with uncommon denominators. So what's a common denominator we could have on both sides, everyone?
5n squared.
Good, okay, so in this first one we have to multiply this by n, and this one by n. The second fraction we have to multiply by 5. And the third fraction across the equal sign we don't have to worry about, okay? So I could even just bring that down right away, 3 over 5n squared. Okay, but going back here now, let's look up here. N times 1 is just n. And then we have negative 5 times 1 is negative 5, so we have n minus 5 here as our first numerator. All over 5n squared. Okay. At this point, we've got a common denominator, and we have two fractions equal to each other, which is perfect for a proportion problem. That's when we're allowed to cross multiply. So let's do step 2 now. We're going to cross multiply. We have to make sure that we have parentheses around here. So we got n minus 5 times 5n squared is going to be 5n cubed. And then we got negative 5 times 5 is going to be negative 25 n squared, which is all equal to 5n squared times 3 is going to be 15 n squared. Next thing we're going to do is subtract 15n squared on both sides. When we do that, we get 5n cubed minus 40n squared, which is all equal to 0. Okay. At this point, we have a problem we could solve. So what can I factor out of 5n cubed and 40n squared?
8n squared. 5n squared. Yeah.
8?
5 times 8.
There's no 8 up there. 5, right? 5n squared? I think what you meant is 5 times 40 is 8. So we got n minus 8. Now I'd like you to finish this problem by yourself. Make sure you check for excluded values. You could work with your neighbor if you like. Go. If you're working this out, you got 5n squared is equal to 0, so n is equal to 0, and then over here we got n minus 8 is equal to 0, so n is equal to 8. And of course, n cannot equal to 0, because if it did, it would make my denominators all undefined. So the only answer is n is equal to 8. Okay. All right, number 4. This one you'll do by yourself. Before you start, think about what's a possible extraneous solution at this point. N is equal to what? 0, right? Because if we have n is equal to 0, it is an excluded value. So that could be a possible extraneous solution. So this one, do by yourself. Check your work as I go, okay? Some of you are super close. I think you just made a silly mistake. Others of you were a little farther off. Okay, so here we go. So the common denominator is 4n squared. So the only thing I have to multiply is this first numerator by 2, right? And denominator by 2. So we got 2 times 1 is 2. Oh, you made a mistake at the beginning. Then we have negative n minus n plus 3. So we have negative n plus a negative 3 minus 3. Right? Y'all see that?
Yeah.
Okay. All over 4n squared, which is equal to 1 over 4n squared. Okay. Now looking here, we got 2 minus 3 is going to be negative 1, so we got negative n minus 1 over 4n squared, all equal to 1 over 4n squared. So we got, now we have two binomials, or two fractions being equal to each other. We can cross multiply. You got 4n squared times 1 is 4n squared. We've got negative n minus 1 times 4n squared is going to be negative 4n cubed. And then we got negative 1 times negative, or negative 1 times 4n squared is negative 4n squared. Alright. Then we're going to subtract 4n squared on both sides. we do that, we get 0 is equal to the quantity of negative 4n cubed minus 8n squared. On the right hand side now, I could factor out a negative 4n squared times the quantity of n plus 2, right? It's all equal to 0. Then we know negative 4n squared is equal to 0, and n plus 2 is equal to 0. Subtract 2 on both sides. We got n is equal to negative 2. Over here, we have n is equal to 0 here. From the beginning, though, we know that n cannot equal to 0. Remember, we said that's an excluded value, so this would be an extraneous solution here. Just cross that one out. So the answer is n is equal to negative 2. Did y'all get that?
Yes.
Or did y'all make the mistake, though? The very beginning, right? So this is a very, very basic thing you have to look at is this negative sign here. Okay? Distribute the negative. So, that's a silly mistake. I think that's a silly mistake. If you did that. Okay? And I'm just going to end the lesson there for today, because I think you do have it.